just noticed something on this picture. These are from the Polish pilots. In fact, I wonder if this has significance that they painted the spinner the same, that the Polish pilots that fought with the RAF. In fact, this was from Lewensky's squadron, 317th Squadron. Again, another thing by having the books that I really like. Little details like this. The early Spits had a much wider yellow roundel. In fact, the roundels are totally different. Just gives you some food for thought, and just thinking about things, looking at that rudder and thinking how that rudder with the ribs showing and how it's all going to look when it's done. Wow. Anyway, the early prototype that had a two-bladed prop and kind of sliced off exhausts. And the model that we're kind of simulating here, the one it'll have, let's hope, going to have the Siamese exhaust. Now, what I was interested in seeing is, this one doesn't have real big valve cover blisters, but it does have a little bulge above that I'll try to simulate with basswood when we actually get down to that. I really can't do it until the top block is installed permanently and the nose is glassed. I'd want the glass to go underneath and then have that be just a superficial piece, rather than carving it in and having the glass go up and around the mountain. See, I think you'll get more strength from having a continual layer of glass around the whole nose. But the idea is, at this point in time, this is the kind of things that get you inspired to go down and get a good day in the shop. Some nice nose section. And by the way, thanks again to John Brodak for sending us. I guess there's 100 tapes. There's 100 hours of tapes there. We are bopping in the 50s. Let's go to work. Again, just looking at one of the definitive things about early Spitfires is the camo changed from being gray and green. The early battles were fought over land, over England in fact, so the camo tended to be brown and green, and the wide band on the roundels, the little tiny center. Later model Spits, the colors changed and the roundels changed. So a lot of food for thought, a lot of options on this model, and a lot of things to think about while we're humming along here with all this 50s music. This is great. It really, I never realized it really does bring you back to your childhood. I can see why people really like to restore old cars and stuff. It was great. All right, down to the shop. Quit fooling around, Wendy. Get busy. Now, what I always do when I get, like when we went up to Norman's, and by the way, thanks again to Norman for sharing all that information. He is one special modeler. I always, when I'm going to leave the shop for a day or two, I always make myself a little note of what's the next step, what's the next thing. And by looking at the list, I realize, see, a lot of times I would get to the end of the model, and I'd forget to put the little holes in so you can get the wrench in and tighten the muffler. Now the plane is painted. Wait a minute. Oh, yeah, it's kind of a pain in the neck. Well, I look at here and I see the next thing on my list is to cut the needle valve hole, and then I need to test fit the tank and make the rear hatch up. So by having a little list to work off, I can kind of finalize this up, because I'm really getting down to the nitty-gritty here on this, where I want to start putting that wing together. So anyway, without fooling around here, and again, I always think, anytime I find something or I remember something that, gee, I ought to do that right now, well, put it on the list. And when you work off the list, then every day you can rearrange the priority of the items, but you basically don't get to the end of the thing and then say, oh, I forgot to cut this, I forgot to do this, not to mention any names, but I know somebody that did not even try to put a fuel tank in a plane until the day they went to fly it and found out, ooh, it didn't fit. It's a problem. Now you have to grind away all that wood where the paint is. So, by the way, Mike, Mike Rogers, I promised Mike Rogers I'd never use his name, and it isn't Mike Rogers, so. Okay, Now, a lot of times, like I said, just plotting out one of these holes, what'll happen is you drill a hole or you cut it in, all of a sudden, when you're done, it's over here, and then you gotta fill in. So the easiest way I know is just, before you do anything, take the cowl off the plane. Now, the first thing I want to reference is the needle valve hole. First thing I want to do is answer the phone. President Nixon needs some help with his paint job. Okay, now President Nixon will help me cut this needle valve hole here. I'll be all set. Now, see, what I try to do is lay this right out. Using a hole that's definitely a little bit bigger than I think I need, because I really don't want to take a chance. It's really not a great idea to have this, the minute you move the motor or you want to switch from one motor to another, those needle valve holes could be off a couple of thousandths. I need to plot this out. Now, an easy way to do this, certainly not the only way, but one of the ways, is to tie this in this way, reference front to back, and work right off the part. Make a little dummy line here. Make sure when I look at that, I have to look that it's going right down. Now I can transpose that line straight down onto the cowling, and then I have my front to back reference point. Now, by sighting right from the front, I verify that that's the height. I can look right in the nose ring here and see if that's exactly the height. So in theory, if that's how far back it is, and that's how high it is, that should be real close to being where I want the needle valve hole. Now, I want to make the hole big enough to begin with, but I'll start with, in fact, let's overdo it. Let's start with a real small hole to begin with, and then we can enlarge it. If we're off center, we can center it as we go. Because usually you will be off just a little bit, but what this allows you to do now, if you drill through a little bit, and you see the hole is off, you can shift the whole piece off as you open it up. Give you a little idea where that looks like it's going to wind up. Now, assuming that it's accurate or close, now I could just carry this up into the top part. Just take a piece of aluminum tubing and tape some sandpaper to it. Make sure I'm right on center. Of course, I'm going to, before I go any further, I need to drill these two holes. I need to get a motor, take a motor out of one of the other planes or whatever, one that has muffler ears, so I can plot those two in, and I'll make sure I have a needle valve. Make sure, don't wait until the day you go flying to do this. But I need to get a motor with a real needle valve that I can line up, and the exhaust outlet. Now I have a piece of music wire that's filed to a point on one side, and I can just drop this down. It's a nice tight fit. This will give me a little impression to work with for drilling the holes. And I can't tell you how many times I've done this and forgot to put the holes in. Well, this one I'm going to have to put the cowling on for. But a piece of 1/8" wire just happens to fit in there perfectly. It leaves a nice impression. Now, at the same time I'm doing this, I can make sure the late model dished head decay models, I have the same amount of clearance around, and that looks like it'll be fine. And of course now I can probe this side and get a dimple inside the cowl, inside the fuse, before I drill holes, and then just use those for reference points. Now another trick, another machinist trick, is just take a little bit of ink from an ink marker. See how it's set into a little dot right there that I can use, and I can drill this from the inside out. So using that little reference point, you can spot the hole. And I'll give you a little reference. Now you can drill from this side out. I left a little dimple of an impression with ink on it, so that'll be real easy. Again, I'll just work a pin through there and then work the drills from the other side. Now, whenever you're drilling through fiberglass, or in this case real wood, it's good just to try to run the drill at a real low speed, rather than having it catch and go bzzz, right through and usually make a ratty hole that way. It perfectly transposes right over. Now I like to take the little hole in the wood part and get a little brass eyelet. Make sure it's an 1/8 inch ID so that you can pass the wrench that's going to go through. In this case it's 632 screws, or 440 screws. Make sure you don't make the eyelet so small that you can't get the wrench through. Now if you can't find these in the hobby shop, I can supply them in a 632. I think in 632 for a 440 wrench passes right through here very conveniently. And it really protects the hole from getting chewed up as time goes by. Now it's easier for me. I like to, before I glue this in place, I like to just take a parting wheel and cut part of it off, just so I don't wind up with, when I'm cutting and sanding here, I don't wind up putting a little gouge in it. Just an easier way to do it. Make sure you have a nice clearance for the tank to go in and out. Now, one nice feature of this type of cowl is you can take the cowling off without disturbing the needle valve setting. You can take the motor out of the plane without disturbing the needle valve setting. So it's an excellent design. It's worked well for me, and I would encourage other people to try to incorporate that into their own modeling, because not having to take that needle valve in and out, and losing the setting every time you want to take the cowling off or shim the tank, it's a nice thing to have in your favor, and it doesn't cost anything extra. I like to look at it from a lot of different angles, put the whole thing together with the real needle valve, the real muffler, make sure you got clearance around everything. So important, and so many times, honestly and truly, I've done it and not done this step and gotten to the end of, oh gee, now I have to sand through that paint. It's really worth doing this right. I don't know if anybody remembers, but John Pothia gave me these, I guess they're like forceps, they're reverse forceps, you know, a little angle on the end, and it's so handy for doing work around the cowling. And I used to always have this little thing where the guy came on view and said, hello, hello. No, we don't do that anymore. We've classed up our act, but boy, these are handy. These are really handy. Thank you, John. That was an excellent gift years ago. And if you want to send me your whole paycheck, I'll take that too. Anyway, trying to lighten this up at the end of the session here. This was a good session. I got a bunch more little details done, and tomorrow I'll try to get that hatch by the back of the tail, and we'll be ready to start the next part of this project. Starting to really shape up now. A little picture in today's mail of John Brodak's, I guess it's his latest plane. Then he was passing on a little tip that I should use 1/4 inch tape. The only time he uses 1/8 inch is to go around sharp curves, and back it up with 1/4 inch tape. And by the way, that does work very well. A nice picture. I guess this is one of John's latest bipes, and he's either eating red spaghetti or something here. I can't tell. Anyway, that tip from John, that is a good one. Hey, by the way, John, we're loving this music. Even my wife took 2 of these tapes and put them in her car. So maybe we can go in the tape business. I don't know. But it brings back memories of some really good times I had when I was young. You mean I'm not young now? No. That's the sad thing, I'm not. Anyway, from John, thanks a whole lot. I also got in today's mail a tip from John Pothier. If you remember back, and I've done this, believe me, Ken's not the first one that's done it. You get the cowling painted, you get the plane painted, you want to see how it looks, so you put it together. And you tighten the screw, and you say, oh boy, that looks good. But now, here comes the problem. You go to take it off an hour later the next day, and it pulls the paint up. Well, John Pothier sent in a really good tip of take the edge and just sprinkle it with talcum powder. Just rub some talcum powder in it. And for everybody out there that's ever done that, I guess with wheel pants too or with other things, the talcum powder ultimately disappears. And I think it's a tip worth trying, especially for Ken Thompson. We won't tell him that though. Anyway, thanks for the tips. Thanks for the picture, John. And hey, I'm looking forward to your visit here in a week or two. Well, a little bit of time I had this morning before I run down to the shop. What I did, I kind of matched up, just like when you port and polish something, matched up these two surfaces a little bit. The reason being is when I look down the air outlets, I don't want to see I don't want to see any. I don't want to see any more than I have to of that little obstruction to the airflow, because I want the airflow to go right over the head or right out these tubes, of course. So that's one thing nice about having this type of construction now. When this all goes back, almost all of the work except for final sanding and then the final finishing, all of this work can be done right in your lap. Now the two things left to do on this fuselage is lay out this hatch and make up the tail wheel wire, and we'll pretty much be finished with the fuselage. But first thing I want to do is carefully lay this hatch out. Now I have to measure since I'm adding 1.25 inches to the tail moment arm, what I want to do is I want to measure this out real carefully so that I get this hatch spaced, and when this is in its arc, I don't want to hit the blind net. Now this, you think this would be very easy to lay out, and when I did lay it out the first time, what I wound up with, this would wind up hitting the blind nut, this would wind up hitting the push rod. It took quite a bit of time to figure out exactly where and how I wanted to line that hatch up. Okay, I'm laying this out. The final push rod length with the adjusted, once you take into account the adjusted hinge line, everything, the push rod itself will be 21 inches long on this model, which should be a very scale look in the tail moment. Should make the back of the body come way tapered back. I need to leave 1/4 inch. Now I need to lay out that hatch. The radius here is 1 1/8 inches on the opening part, the part that's going to be removed. I remember doing this the first time we laid the hatch out. And you run into all kind of problems like the push rod hitting things and the little catchway, and by the time you lay this whole thing out, you realize once you get it laid out, don't change a thing. And it's worked good on all the models we've made. You don't really have to be a rocket scientist to figure out this would be a great time for a new XL blade. Get a nice smooth cut on this area. Now what's handy to have is you have a piece of old broomstick and just tape up a piece of sandpaper to the end of it. gives you almost that exact radius that you need. Get a nice smooth edge to start with. And I want to seal that edge with thin CA before I go any further, because I don't want that to start to deteriorate and change. And of course, where the joint of the sandpaper comes together, just leave that in the back. This gives you a nice edge. We haven't had to cut into the carbon fiber, so that'll give us a nice straight line right down the fuselage of strength. As soon as you get that on there, ooh. What that does, that hardens that edge right up. Now I'll re-sand this out and I can work off that edge. Another nice use for these Bud McKnight sanding sticks to get right in there and dress that edge off. Hard to imagine that there was a time when we worked without these things. I want to do the same thing on the edge on this with the thin CA. So I'm working with two relatively hard straight edges. Now I'm going to head out to work, and I'm going to get back here this afternoon. I hope and get another session here, maybe finish up some more of these little details. I'm going to make sure I have a nice tight fit. Anyway, this is just one of the things I'm in the process of trying to pretty much make a kit where I can make as many of these parts as possible so that when I actually come to do the final assembly, as much of this is done and I can just go right through it like a lawnmower. See, that's another nice little tip is I like to work on this a little bit in the morning when I get back from work. In the evening, late after supper, I like to do a lot of little sessions. And even just getting a couple little things like this done now, I'm just one little step ahead, and I can think about what I want to do as far as the next step is. I'll have all afternoon to think about it. Alright? Just another great tip, a tip you can put right in the bank. Because a lot of people really get bogged down where they're facing the next step and they don't know what the next step is, or they do it out of sequence. That's why I hope one of the things you can get off the videos is. Alright, this afternoon, I don't even know if it's afternoon or night, but I want to lay out this piece of plywood which actually forms a little, it serves two purposes. It stiffens up this area where in effect we've weakened it with a big hole. It also serves as a little edge that when the final hatch goes in, it rests on the edge. And I'm going to just cut this out of 1/64 plywood, pretty much tracing it right off of the sheet. Now the whole trick here to make this easy is to lay the piece out before you actually cut it out and put the little reference hole, because there's going to need to be a hole down hole and a blind nut, and of course you can copy that right off the plans. But by doing it now, it just makes it a whole lot easier when you go to assemble this. Now I need to mark the hole here so I can drill a hole for my screw and my blind nut. So what I'll end up doing, putting the blind nut in a piece of 1/8" light ply, and because it's so close to the edge of the balsa, you need to be able to get it as close to the balsa if you want it to be accurate as possible. And our next step, of course, is to get this fit right into the fuselage side so that the same perimeter of edge is showing, and just tack glue it in place and make sure I get all the fits right before I go any further. Now here's a tip you may be able to use in a lot of other ways. What I always try to do, and it's kind of machine shop procedure, is to have something to get this lined up just right. Because I don't want to get all done and then have the bolt not line up. So what I try to do is bolt the two pieces together. Just get these test fit in place. Then I can tack one drop of glue on it. Now see, I can move the hole and get equal clearance around everything before I tack glue this. And that bolt is holding it in place. It's giving me the full alignment here without a lot of extra work, without a lot of extra fooling around. Now what I need to do now is this is now my locating piece for locating the hole. I need to make a little lip here for the 64th plywood, because obviously if you left this just in balsa wood, eventually this would come right out the other side. So I'm going to cut a little piece of 64th plywood, glue it in place, and then use this as my centering hole to drill a hole for the screw. And I have these real nice aluminum screws that, believe it or not, Frank McMullen sent me a couple of years ago. You can get these from Micro Fasteners. And of course I'll trim it to size when I get it all done. These are really, really nice little handy things because they're flush. And you can sand that right in when you're all done. Because I want to relieve this piece, I need to just get in there with the tip of the blade. I want to relieve a 64th of that material. And this is just a little piece of 64th plywood. It just acts as a support. I want to make sure once I get that in there that it's flush, otherwise this would spring out. So I just need to relieve it or even press it down just enough before I glue it. Now it's just a question of using that hole, and it should line this piece up perfectly. And see, that's part of, I guess, any engineering little project or exercise that you do, is always having one piece line up the other piece. Same thing with the cowling hole bands, landing gear blocks. There's just a million little things that if you have the sequence down, the rest of it just follows right in order. Save yourself an awful lot of time. Now if you press that screw in just a little bit, actually the first time you tighten it up it'll leave a little impression, then you can harden that impression up with some thin CA, and it gives you just about the right countersink, so that little bolt head, when it's finished, you don't catch a towel on it every time you wipe it off when it's finished. Now the only thing left to do is make up the little tang on this side. That the way this works is this gets pushed in, and then one screw holds the whole piece in place. And there's a little hook tang in there. That's the only piece left to make up tonight. A little bit of thin CA will harden it up. Have a nice little countersink there. Nice and neat whether you use that on a cowl, gear blocks, whatever. It works real nice. The other thing I want to do is get a parting wheel and trim that extra amount of screw off of there. I don't want to have anything hanging in here. And either way, I don't want to have the weight anyway. We'll just trim that off, drop a little oil on that bolt, make sure no CA gets in there when I put the final glue, and I'll put a final glue seam now on everything that's in there. Of course, without the hatch in place. So that's what I want to have. I want to have all the threads caught in there, but I don't want to have a bunch sticking out inside the ship. Now all this is just a little piece of 64th plywood with a little bevel, just to make a little tang so that that side can be confined. It eliminates having one screw on that side. You can see how that little tang works. This is really a nicely, it's a well-engineered system. Both Joe and I have used this on the Spitfires, and so far it's proven to be just about the nicest way I've ever seen to make a hatch. One aluminum screw, one blind nut, maybe an hour of labor, and you have adjustable controls now for the life of the airplane. Now with the hatch in place, you do a flash, it's usually just a couple of swipes of sandpaper and you got it right back. Today's restoration project, I'm only going to spend a minute or two on this, I bought this antique gold mirror with Karen the other day, and there's an awful lot of little spots on it that need to be touched up, and we bought some rub-on gold leaf. We want to see if we can restore this frame. You can see where this is kind of a gold leaf finish, and it's been ruined by probably sitting around and nobody taking care of it for years. What I'm trying is some M600 on here. Every once in a while you can get M600 to take off some of this, whatever you want to call it. This doesn't seem to be working great, but it's taken some of it off. And we bought this stuff in a craft store. It's like a rub-on gold leaf product. I was thinking maybe we could use that. But the latest thing, the greatest thing, we bought a 100-year-old stove. We're going to restore that stove for our kitchen. Don't have enough projects to work on around here. That takes some of it off. Sometimes you just have to keep grinding away at it. The M600 seems to take a lot of that oxidation off. And what we did, we tried about 7 different chemicals. Probably the best one is old 3608S. Just letting it soak in. You know, we have some rub and buff that any of the spots need to be touched up. Actually, if we had an old toothbrush, you have an old toothbrush upstairs, that'd probably work good too.
We could use yours.
Yeah.
Yeah, I'm sure.
Right,
sure I do.
Just keep going. This is the stuff we got in the craft store, rub and buff. It touches up all little spots when you're doing an antique gold finish.
Looks like gold leaf.
Like gold leaf. Well, I think it's going to look nice. You get the glass all cleaned up. Try not to get any of that on the glass if you can help it.
Wipe all that away.
Yeah, and just buff it away, whatever's left on. Wow, that's a good tip. I can see Bill Hummel right now saying, okay, let's go buy an old mirror. I have nothing to do this Saturday.
Annie, make him work.
Annie, put him to work. Give him something. We found an even better tip. A little flux brush. Rub and buff and a flux brush.
Yeah, it's working great. Getting in the nooks and crannies.
When you think about, when you go to these antique places and you see these mirrors when they're really restored, I mean, they're tremendous money. Something like this is a fortune. Well, you can buy it, and just all it needs is a couple hours of restoration. See, when you buff it, it's just like buffing a plane. And the buffing, the high spots come right off. You can do this for a fraction of what it would cost to buy one of these guys already restored.
Oh, it's fun these days.
Well, it's not fun.
I'm enjoying it.
I could be working on my Spitfire now,
I'm
but
lazy. I'm enjoying this.
anyway, life is more than just toy airplanes and couches, believe me. I don't know, nice little project. Kind of matches this little fireplace that we've rebuilt ourselves. Hey, it's been fun. If you have any love of old houses, old things, hey, my wife even loves old men like me. And this is the product that we use for whatever it's worth. Look at this, $2.50. And you can turn something that really looks ratty into something that you're proud to own. And it's fun. And then you take all the money you saved and you go out and buy your wife a nice Valentine present. Buy her a doll. Buy her a Siamese cat. You can buy her a fish. Or you can buy her a concourse trophy and tell her she's the most beautiful woman in the world. Now this is from today's mail. This came from David Lovegren. It's a Cardinal kit, of course. Some modifications he made. The main modification in the kit was the use of a molded Strega top block and a bubble canopy. I'm just reading some of the details. Says powered by an ST60. And what he did, he replaced the block right behind the spinner to make the nose a little more rigid. Everything else was straight out of the box. He also gave me some real good suggestions on updates for the kit, which we're in the process of doing, by the way. Every batch, for anybody that doesn't understand, every batch of kits is automatically updated with all the new stuff that, basically from the feedback we get from other people, like David. It's got fuse-mounted gear. Kind of looks like a Thunderbird in this picture. Anyway, thanks to Dave for the pictures, and we will be passing these. He's from London, Ontario, Canada, and we will be passing these on to Stunt News. Bill Rich. Who else? Bill Rich. Just looking at some of these old photos as I put these photos away in my album. One of the many ships of Derek Pickard. Now look at the nice geodetic tail, nice tissue work on this, and again from Derek Pickard. Bob McDonald Strathmore. Well, I'll tell you, I don't think there's anything more important than once you get older, once you get old, once you get to be my age, than having some of these old pictures to remind you of what great times you've had in the hobby. But without these pictures and without the videos, I think you'd forget a lot of this stuff. Vic Macaluso at one of our recent stunt forums. Old albums, old pictures, old videos. The older this stuff gets, the more valuable, at least to me, the more valuable it gets. Oh, look, here's a good picture. This is the first time I ever flew. This is a picture of one of my first flights from the Walker fly-off with the MiG. I mean, how do you replace this stuff? Well, if you get one suggestion from me, save every photo you can and store it, save it, and share it. And if you can get it on video, it's so much better. Then you can share it with the world and still keep the photo yourself. Anyway, thanks to everybody that's been sending me photos over the years. They all wind up in Stunt News eventually. Now just thinking of one thing before I get on to working on the plane. One thing significant. We were just out to Norman Casella's and I got to see that laser that he has, the RC. It's about, oh my God, the most impressive thing you can imagine in real life. But just thinking of now, both Gid Atkinson and Bob Whiteley have both done really impressive stunt ships of lasers. And I really, as time is going by, I'm thinking more and more this would really be a nice topic for, maybe for a John Brodak profile laser. And maybe, just a thought, if this was a profile body, you could mold up this whole cowling. It would cover the engine, the tank, Hey John, think about this. And yet the rest of it could still be a profile. Anyway, this is how you just get ideas from. Both of these planes really were really impressive. You could have the little flying wires. Again, I'm always trying to come up with ideas. Every time, before I go to do a day's work in the shop, I like to look around, look at my Spitfire books or something, get inspired. Here's just one more reason for saving all your pictures. This is Nat Gifford. Look how young he is. He and Carmen DeLuca holding his plane. Carmen's not even in the hobby anymore, but imagine the good memories you lose when you don't have these kind of pictures, or you don't have the video copies of them. Either one. Matt, I guess you were a pretty cute kid. I don't know. You should see him now. 6'5", he's a bodybuilder. Hey, my kind of guy. And there's one picture more than any in the whole shop that I look at every day, and this is the one that's behind my desk when I was almost dead of pancreatitis back in the 80s, and it reminds me, take care of your health, take care of the memories. Hey, let's get to work in the shop. Got a lot of stuff to do today, and appreciate the good times you have. Now, what I wanted to do today, I only got about a half an hour of time here, but it's what's happening. Mike Kajeski is going to be doing some contractor work on the house, some structural work in our kitchen, cutting a doorway, and I want to be with him most of the time, giving him a hand. What I did, I laminated up, I'm going to laminate 2 more, in fact, 4 pieces of 64th plywood to make up the tail wheel mount. Now see, and this is just one of the things you can do. When you have a little time, an hour here, a half hour there, you can make up little component parts that go into ultimately what will be a kit. So this is what I mean by doing a kit. I really wouldn't have the time right now to lay out the wing or to lay out other component parts that are very labor intensive. But every time I have a half an hour or an hour that I can steal, I try to make up a little component part or some little part that'll just get me one step further into the future and make up the hinges, or I can make the belt crank up still. And what I did, I made up a list of all the little things, and one of them is the tail wheel. So today I'll try to get that at least framed out. One less piece I have to worry about when it comes time for doing the actual assembly. And turning it into one of these guys. Now the easiest way that I like to laminate the plywood is with each one the grain going in a different direction. Picture of 4 different directions. And then each time, once the pattern is made, cut out the part and lay it on with the grain going in the opposite direction. This way you really maximize the strength. You're really making a part that's really lightweight and really durable at the same time as saving a little bit of weight. You make this part out of plywood that only has 3 or 4 grain directions, it's not going to be as strong as this, and it's going to be heavier. And every time you can save a little grain here or grain there, it's more, well actually in my case it's more details I can put in the plane, because I'm not looking to make the plane ultra lightweight. What I'm looking to do is save some weight so I can put more canopy details, more cannons, more landing gear details, more scale-like stuff on it. Now I'd want to get the grain going the opposite. The 4 laminations will usually make a piece that's pretty strong. Again, I think it's always easier to make a pattern and laminate one part on here rather than trying to make 6 parts and then glue them together and they never seem to line up right. And when you sand them in, it's always easier to do it this way. This is a real time saver. Now the object here is to get a nice tight fit. So I saved the last little fitting, make it a little bit oversized always. The last little sanding so it'll stay in by itself. I want it to be on a little bit of a swept back angle and go as far as the hatch, because what that does, that adds in effect a geodetic form. It's actually going to add strength at the spot we need it the most, right where we've lost the strength from having this piece of the hatch removed. Now I know I have the shape real good. I can dress this edge right off and bend up some wire. And believe me, there's one thing I recommend. Don't make a springy tail wheel. I've seen so many planes, when you go to launch the plane, the tail wheel's like a big rubber band. They try to use thinner wire. I like to use 093 wire no matter what. Or if you're not going to use 093, put some kind of a scale tail wheel decoration on it that stiffens up the wire. A springy tail wheel is like an accident waiting to happen. Now, a couple of ideas. Keeping the tail wheel as light as possible and as strong as possible. A couple of things that help. If you have the wire on this side, it actually uses the back of the plywood now as a pivot point. So really, you're taking a lot of the strain off of the little copper wire. If it's on the back, it'll just tend to break the copper wire. And I know most people, you never see a tail wheel break or anything, but when you do see one break, like what happened to Bill Rich at the Lincoln Nationals, and you've got to replace this and cut into the plane and get a coat hanger wire because you don't have music wire, it makes you crazy. It ruins your whole day, among other things. So my suggestion is take the time at this point in time and do it right. Do it as if it's a real important part of the plane, like the control systems, because it really is. You know what I do when I bend up the tail wheel wire, and again, if you want to put some scale detailing on this, you want to make a swivel tail wheel, and this is a good time to do it. But if you're going to do a standard tail wheel, which is what this will be, I want to sight down there and see that I don't have the tail wheel canted out or canted in. For starters, I want to have it perfectly parallel, and it's easier to bend the wire right at this point in time than later on. Now, one of the things I want to try to accomplish with a tail wheel, again, more details. It's hard to believe that these little details all add up, but they do, believe me. Ask anybody that's ever broken a tail wheel and how to fix it. Here's one of the things. I always want to have the landing gear, the leg, facing in at me so that if the solder joint broke, centrifugal force would keep the wheel on instead of spinning the wheel off. I always want to have the wire in the front so that it's pressing back on the plywood as a footprint, not working against the thin copper wire. So to do this, I've laid this out, and I can pretty much just trace this now, making sure I get all the angles right. And I want to run a series of little holes around here and get some SIG copper wire. Go ahead and readout wrapping wire. Now the idea here is to drill a series of holes, like shoelaces, as small as possible. You don't want to drill 1/8-inch holes, it just weakens the wood. You notice if you drill it through 1/8-inch plywood, it tends to split the wood and splinter it. When you do these thin laminates of 64th, it really works out a lot better. So if it's helpful, you can do kind of this and just give yourself a little drill pattern to work with. I know a lot of these details, little things that seem to be insignificant when you spend 50 hours to build a plane, when you spend 100 hours, you really don't want to take a chance they're going to break, and when you spend, 400 or 500 hours, you really, really want them. I mean, I expect to spend that much time. Even though I'm doing it in little bits and pieces, I'm doing it working around a lot of other constraints, it still seems like the plane is moving right along. Again, SIG lead out, the wire that you use to wrap lines or lead outs or whatever, thin copper wire seems real good for doing tail wheels. What I do, I just try to do it like a shoelace and then go back. Once I get to here, here's where you're going to have the maximum amount of stress. And just, when it gets to the end, then go back until you run out of wire, twist it shut, and put some CA on it. What I want to do, I want to take a real nice impression of this tail wheel right in some soft 1/8-inch. And you can see the lasting impression is. Now what I want to do is I want to trace this out. Just get a rough idea where this is going to be. Using some thick CA, laminate this part right in there. I can just trim this edge with belt sander right there. when I'm all done, of course, I soak all the end grain with thin CA, get a coat of CA on everything, soak it and let it soak in. The reason for that is and it always happens, it's especially bad if you have a tuned pipeline, the oil is blowing right on the tail wheel, it tends to work its way down in there and turn the back part of the fuselage into a little bit of a sponge. So whether you have a normal plane with a muffler or if you have a tuned pipeline, you want to keep oil off of this back area, that's for sure. Now, one final thing. I like to now that this is all done, I like to do a little bit of a test fit, make sure it's a press fit, that I can get a little bit of an angle backwards. This is one more step toward completing this plane, in any plane, no matter whether it's a Banshee or whether it's the most complex plane in the world, is made up of a series of parts. And if you can make as many of the parts one by one by one, see, this is what stymies an awful lot of people, is they get to a point where they, gee, what's the next step, and they go in the wrong direction. Well, like I'm working around the constraint of working on this house, and when I don't want to put the wing and start the wing, be in the middle of doing the wing, and all of a sudden, I got to go rip a wall down or something. I'm trying to work around it. So, and I'm sure everybody has these same things, but the main thing here is I have this set now, so for me, this is going to be one less part that I have to manufacture when it comes time to actually get this plane put into one piece. You see I had my little priority list here. I can cross the tail wheel off. Now the next two things, I'm trying to get all the little things done that I can before I actually want to put that wing through the body, all these little details. I can make up the belt crank and the push rod, but I'm not going to have enough time to start that now, so the next time I get a session, I'll just add that to my list. And there's some reward toward every time you make one of these parts up, knowing that you're one more step further into it. Again, if you weren't working around all kind of construction restraints and trying to reorganize a machine shop and things like that, we weren't working on Kenny's shop, things that have dominated a lot of the time, this project would be a lot further along. But as it stands, I'm trying to go methodically, slow, and get it right the first time. A little bit of time I have here, I guess I could put the bell crank together. There's a couple of things. Joe K made the die for this bell crank, and originally we had several thoughts in mind. One was that we wanted to make a bell crank that was totally indestructible, and we left a car engine hanging from it over the weekend. We also wanted to have the bell crank itself be the bearing material, not have pressed in inserts and bushings and screws and nuts and washers and lock washers and things that can loosen and break. And this is about the simplest system that I've ever seen. It's proven to be so bulletproof that we've never ever had one failure. Now what I want to do, this bell crank was originally made so that, you see where this is a press out pin. This would be the ratio for a slow control ratio, this would be for fast. This would be, in other words, if you wanted to use a relatively large handle, this if you wanted to use a relatively small handle. Now I never put the pin in here because what I didn't want to do is confuse people. We had made horns and bell cranks in the beginning that all were a matched set, and they were basically to the specifications that Big Jim Greenaway worked out, and those specifications have served us well over the years. But this plane I'm really fine-tuning based on the last two planes that have been built, and I'm going to use the slow control ratio. So what I'm going to do is just drill this hole out with an 093 drill. I can actually remove this part of the bell crank, and I can also get a little Dremel tool end and I can lighten up some of this material in here. These are so overmade and they were so overstressed on purpose that getting rid of a little bit of the material isn't going to hurt anything. Again, it's a bearing material, and you can see just there's no resistance in that at all. Never had one of these where you don't want to use a ball bearing. A ball bearing is not good in any case where there's vibration. And you want to, if you make your own, obviously, bell crank out of Delrin or some other plastic material, make sure it's a bearing material. The first thing I do is where the solder joint is from this point up. I just want to put a few serrations on this. And the serrations are so wherever this intercepts in fact I can go over to the spar and see where this is going to intercept so that it gives me a little bit of a tooth for the epoxy. Okay, here's actually the molded carbon spar. This is how it's going to mount. So what I can do, real carefully now, I can do this, is I want to mark this, where this will intercept here. Actually, it doesn't even matter. It'll be 1/4 of an inch out from the pivot pin, and serrate this because I don't know how much of this is going to stick up and wind up pressing against the fuselage doubler. So it won't hurt. I'll start from this point out and serrate that wire with a parting wheel. And you can see the side. On this side is serrated as opposed to just the music wire side. We also want to somehow confine this when we're all done with a cap, top and bottom of real thin plywood. This is a real good thing to do. It really gives the epoxy a real tooth so that even if in time, years go by, you get cracks in the wing, you have a crash, anything, this is really a cheap insurance. A couple of things you never try to overdo on any I-beam plane is make this center section of the wing any thinner. In fact, you see how I've carried this out way farther probably than it has to go, but you wouldn't want to have, and I just remember in several planes that I've seen fold the wing, is because they've made the cutout for the belt crank. Jack Petrolia's Aries, in fact, that inside wing just came right off. So we really want to make the pushrod hole, the hole where the pushrod is going to come through here, I don't want to have this any bigger than it has to be. The last thing I can do here before I got to leave for the shop. I got the holes drilled. I'll finish doing the work on the belt crank, make up the pushrod, the arrow shifts. Maybe the next time we get a little session of work on it. But for now, any little step I can get done, hey, especially when you have a limited amount of time, it just makes everything go quicker. Okay, luckily I got another hour to work on this, so I'm going to try to do a little bit of the work on getting rid of some of this extra material from the belt crank. I can get rid of this whole extra length on the arm, maybe even get the arrow shafts made up. One last look at the kitchen. Today we ripped all the paneling off the walls, ripped the light switches out, ripped the electric boxes out. This used to be a nice kitchen. Say goodbye to the flowers, hand painted. Say goodbye to everything here. We're going to do this whole kitchen over. So there'll be a little bit of a break in our Spitfire development program. You know what's nice if anybody that's ever done any renovation work, you know this is what happens. This is what your house looks like for about 6 weeks. Plastic. Even put big dollies under plastic. Oh, God, why can't I just build models and be done with it? With that mess going on upstairs, I want to do some more work on the few parts I have left to put this kit together. And I'll probably, in the course of renovating that kitchen, have the whole fuselage kit finished. Now, I always like to do a final little check on this before I make the push rod up. There, we've got enough carved away. And that's pretty much how that's going to sit in the airplane. Now, you can see there's a limited amount of clearance between where the belt crank is going to pivot and the push rod. So the little end that I leave on the arrow shaft, I want to leave a little longer than, certainly no longer than it has to be. I want to look at this movement and looking at it, it's probably just a little bit more than the thickness of my thumb. I don't want to make that little stub on the end any longer than it has to be.
Now when that's centered, and of course I want to have it centered, you can see I do have a limited amount of clearance. And see, the thing I don't want to do is hog out a big giant hole here. And when I look from the top, I don't want to have any more length than I need. I want it to just about run out of length when it's right at the very end. So what I'm going to do is I'm going to make up the little wire end before I actually make up the push rod here. Now, a couple of tips about bending music wire worth repeating. You never want to bend the wire, bend it too far and bend it back. Bend it once. If you've gone too far, just make another bend. You never want to make this bend so sharp. An example is you don't want to put this in a vise and hit it with a hammer. You make this 90-degree kink and it fractures the wire. The wire almost always fails in service when you do that. You want to get a nice radius bend, not a sharp, pointy bend. Now this is just to establish I want to leave a little more length. I'll make another piece of wire, but I want to leave a little more length, but I don't want it to hit, obviously, either side here. And I have enough clearance, and I don't think I'm going to have enough clearance for the push rod, though. Now, an example of what I'm talking about. Maybe I don't really even need to worry about this. When I add the thickness of the arrow shaft, I don't want it to hit this piece here. So by looking at this, it looks like I'm going to be okay. It looks like it's not going to be a problem. I won't have to hog. What I didn't want to have happen is that, oh boy, I'm going to be hogging a bunch of that out. So it looks like I can put a very short end on this. I won't have to make it any longer than normal. But I do want to make this end a little bit longer because when I do the solder joint here, I like to keep the heat away from the nylon. A little bit further, maybe add 1/8 of an inch to that side and we'll be all set. But anytime you do this kind of wire stuff, never go back and bend it. You only get to bend it back and forth 2 or 3 times and it fractures internally, or it'll fracture up here, and that's when you have a failure. These are the little arrow shaft ends that come with the Dave Brown arrow shaft kit. There's only one problem. None of them come with an 093 hole, so now whether you're using the ones that are a lot smaller or a little bit smaller, you have to run an 093 drill through them. Which, by the way, it's a good idea to invest in an 093, an accurate machinist drill, because the horns should be soldered, the bushing should be soldered in place, and just run a drill through slightly so you have a nice tight fit. Again, a drill is about $2 from any machinist supply store. It's an accurate drill. It's not a hardware store drill. 093. You really need that to be a nice tight fit. If it's a sloppy fit and you fill it with glue, it's a problem. And if it's too tight, you can't get the wire to get in there, or it'll split the arrow shaft. Having that machinist drill is really a good investment. I like to set this wire up again so it's so tight you need to pull it in with pliers. Now you know you have that really good tight fit. That is not going to loosen up in time. Normally we would put the bend up on this so it would go through the arrow shaft. Because we're going to be going through that tunnel in the spar, I want to have this coming out the side facing in. Now what I need to do is lay out the push rod piece and just leave, look at this, President Nixon, just leave just enough on here that it juts up through the arrow shaft. Now again, another good place to use that 093 drill for a nice tight fit. Again, this is a really tight There it goes. want to have that sticking up through the arrow shaft. Now the last little bit, I can push this back down. Now I always like to take a little bit of carbon fiber tow. And if, by the way, if you don't want to buy a $250 roll of this, anybody that calls me with the correct answer to this solution will get free carbon tow. Anyway, we don't know what the problem is yet, but this is a good way. I think just by wrapping this, and I have seen these split on the end. They don't split right away, but when a plane is 6 or 8 years old, it can happen. And that's right about when the plane has won its 5th national and its 3rd concourse, and you're so happy you're leaving it in your will to your grandchildren, and that's when it usually lets go. So I just tack some of this stuff on, run this right around, hit it with thin CA. You can see it all wants to defray already. The main thing is to get it around that little nub of the push rod that sticks out. This really does make for a bulletproof 10-15 year control system. Now see, I can just see the tip of that wire coming through. I know I've got it built up a 1/16 of an inch or so. It's locked in with CA, and I just want to clean this up. Remember, the gods see everywhere. Even though this is inside a plane and nobody's really going to see it. Let's hope. The old Bud McKnight sanding stick goes into action. There's another perfect use for it. Now we're going to leave this end just extra long, because once this gets into the fuselage, I won't put the back end on this until I know exactly where the control horn is, and then I'll make my adjustable zero-in feature in the back here. But for right now, one end on here. What I also did, I don't know if you can see it up on here, is I put some notches. Let's see if I can get this zeroed in. Some notches in the wire, just the whole safety wire. When I solder the eyelet in here, I want to have a little safety wire on there. It's a redundancy system, and I use that on all the soldering joints, and always stay bright silver solder. The next clearance to set, of course, is when this goes through its travel, you don't want to have this hitting here, so I want to set that clearance, make sure I've got it. Yeah, it's about 1/8 of an inch or 1/16 of an inch. Another thing, don't be suckered into doing this. Don't be suckered into making this push rod up like that. The higher this push rod is, the more it's going to want to bend and flex. You'd really like to have this as close to the bell crank as possible without hitting. So wrap that copper wire, use a little eyelet. What that does, it keeps the heat away from the bell crank. Even though this material will take a certain amount of heat. Now you always want to use Stay Bright silver solder, no substitute, and you want to deflux it with baking soda and water when you're done. The way you can usually tell if you have a really good soldering joint, it'll be shiny when it dries. Stay Bright solder and flux. It melts at a much lower temperature than regular solder, so it's the ideal choice for soldering around plastic or bushings or whatever.
Now, I always like to show this on every video because this is a critical thing. This is baking soda and water, and I just add the water each time. This is defluxing agent. What you do, you put some of this on a Q-tip, and it neutralizes the acid. This flux is sulfuric acid. And you don't want to get this on your hands or in your eyes or in your nose or anything like that, you know. Not that we're all EPA friendly here or anything, but the baking soda and water neutralizes it, and then you want to wipe it clean with a little bit of alcohol. And one jar of this, I've had this since I've been in business, like 11 years. I've never even cleaned the jar. You just keep adding water to it, and whatever sinks to the bottom, you can turn into new defluxing agent.
And you can see when a joint is a good quality joint, it's usually relatively shiny. And once that's cleaned, it still has a real nice tight, there's no extra play in there yet. And I've left this just extra long. I'm going to put the lead outs in this, and that's about all I'm going to have time to do right now. Now normally when I wrap the lead out ends, I use 48-inch wire, it's 032, and I try to let this end sit at least 1.5 inches, 2 inches back in, and I've put a piece of copper tubing on it. But another way, and I just want to show various ways of doing it, is with the thin copper wire. That's another good way of doing it. Now this 48-inch music wire, I usually take a 3M pad and get some of the coating off it. The coating just keeps it from corroding in storage or when it's in a damp, moist area. But whenever you're going to solder, of course you want to take they usually use like an oil bath. It's 032 wire, and I wouldn't recommend less than that on any plane, period. Just like I don't recommend anything less than 1/8-inch horns. Anything bigger than a 1/2 A. I just feel like the heavy-duty controls have served me well, and any time I've not used them, I've always regretted it. Now, the little trick that I use is not to bend these bends at totally 90 degrees until you slide the bell crank through, and keep this dimension just as thick as the bell crank. Then put the last little bit of bend in once this slides through. You see, by not having these bends totally at 90, it allows this to slip through without a lot of bending back and forth. Now what I want to do, I'll just use the bell crank itself as the fulcrum point to just get these back to 90. And one thing I don't like to do is put a nice kink and try to get these right up here, because then you have this little piece that's doing this all the time. As you're putting stress on it, it's doing this. The further out you can put this joint, the better it is. The more it's in a nice straight line parallel to the force you're pulling at. Now it's not a whole lot different than just wrapping a lead out end. But you want to make sure before you put the solder on it, you have a straight pull. This is why, in a way, using the tubing pieces is a little easier, but I like to show both ways on the tape if possible. There's always more than one way to skin a cat. There's always more than one way to wrap a lead out, or more than one anything. And I guess that's part of the beauty of having the tapes. You can pick the way that suits you the best. Important is to make sure you have a nice straight pull on this. It's not pulling up or down. Get a nice straight pull before you put the solder on there. Now that's another piece in the puzzle. One more little piece in our trying to get this prefab kit going here. Again, anytime you can make a little part, you can get that much ahead. Well, I just love this. I love looking at it every night at the end of the night and seeing all the little pieces. It all starts to look like a little airplane sooner or later, and it's coming up on the time when it's really going to be an airplane. Now, the only thing I have to do, and I'm not going to have enough time to do it tonight, is to make up the push rod. Let me try to get to that tomorrow maybe, but I got an idea in the mail from Bob Martens today. It's absolutely worth sharing. This is the part of modeling I really enjoy. Now, one of the ideas that I've had right from the very beginning, I was making up these molded shells, and even the first effort I had at doing it, what would happen is when you'd mold a piece over the top of this, you never could pick up this line where the mold ended. This line was always a very vague thing. When you'd mold this shell, this piece would be oversized, and picking up this line accurately so you could drop this down on the fuselage side was really a problem. Now, I came up with a solution that really boils down to I would take this piece, which would be the cross section, and I would glue it to another base plate. And then I inserted these little pieces of wire here so that the wire would leave an impression. So that when you took this shell off, and the shell was basically over the top like so, what would happen is you could pick up, great artwork, huh? You could pick up in the inside of this shell, I'm sure everybody's seen this a couple times already, but there would be a line in here and you could use that for your trim line. Now, Bob Martens even came up with a better idea than this, and this is what blows me away. This is what I love about modeling, is just coming up with these little techniques. And Bob gets the full credit for this, that's for sure. Now what he had in mind was, I guess, and he's going to try to, I guess, expand on this. Let's make this a little bit bigger, that this is now your mold, and you have the little base plate down here. And you want to get a real accurate trimming of this shell. Well, the idea that he had was, if you put this on a flat table and you run your little router bit up here, just like we put the hinge pockets in, a little parting wheel even, a little saw blade. Okay, now what happens when you take this and run this mold block right down on the table, it gives you exactly this line according to the height you have up here. Now, what made this significant now is, let's say, and I have to keep expanding this, let's say that this was the original plane you wanted to make, and you wanted to extend it another 1/16 of an inch because you were making a wider fuselage. Well, you could set this, lower this down just a little bit so it would take a cut off the table like this as you slide the block down, and it would add that whole 1/16. So that shell would now be a 1/16 of an inch thicker in this dimension. And again, just like in our visit to Norm Casella, picking up an idea from somebody and then using it, sharing it. Now that shell is now, let's give it some dimension thicker, and we can use it on a wider fuselage. We've added this amount to it. Now, I can raise and lower this little, let's call it a router bit, cut-off wheel, same as any other router bit. And one of the things it allows us to do, and I have to give Bob full credit for this, let's say you wanted to make a turtle deck and you wanted to add a little more sweep to it. So in other words, you wanted to make the front a little bit bigger but not the back. Well, what you could do is take this shell and just follow through with me. Shim one side up with a piece of 1/16, 1/8 inch or whatever, and then together run that through the router bit. So in effect, it would take more off at one side. See, I'd have to exaggerate this. If I wanted to add an 1/8 of an inch here and a 1/16 here, and this is well exaggerated, I would need to shim this side up off the table so that we're working off a flat table, and now it would take an uneven cut. I wonder if I'm explaining this right. Anyway, I'm trying to get Bob's idea across because I really feel like there's so many people using molded shells now, and I get calls about it all the time. How do you get that line in there? And how do you, especially the guys in Europe. I know Uwe Degner's using these shells. I know other people that have ordered a shell and then gone out and made their own. But what I'm getting at is you could take a Spitfire turtle deck, a Nobler turtle deck, and you could alter the angle of it. Now let's just pretend in redrawing this will be your custom version of a Nobler. You want this turtle deck to look like that. Well, you can't do the red of it. you want to make that piece. Well, you can add this amount here, just to the bottom of the shell, and pretty much the idea being here is with one mold you can make almost every turtle deck. With another mold you can make, even if you make it oversized, this nose can now have a lot of taper, almost no taper at all. You can put a various amount of taper in this. Now what I'm hoping is going to happen, and of course same thing with the bottom blocks, you can have these taper a lot, taper a little bit. But what I'm hoping is really going to happen, Bob is going to, and Bob, believe me, we appreciate the accuracy, I appreciate it, of all your drafting. He's done the drafting for the Brodak Cardinal, the Seafire, the Spitfire, the whatever, Gevilta fishes, future planes yet unbuilt. But what I'm getting at is with one core fuselage, you can make turtle decks that have more like Frank McMillan's Quadrant has a lot of rake. Bottom blocks that taper up in the back, like in Aries. Really, with one set of molds, and this little technique that Bob has kind of just put the seed in my brain, we are going to be doing more of this in the future. And you can bet, the other thing is we've only scratched the surface. There's more. Anytime somebody comes up with an idea, then Bob makes it even better. Somebody else is going to come up with a better idea. People are always adding. And when we combine all that, the idea being that you never have to carve blocks. Now just looking over, this is the Spitfire, the original mold that we made for the original Atamusco Spitfire. Now just look at what you could do just as an example. If you want to add 1/8 of an inch of thickness here, imagine you could set the rod a bit and just make the whole piece. You wouldn't even need the wire. That's the nice part of it. You could lose the wire, in fact. You just would need to extend it down some amount, and that would be the biggest amount that you would need to use. But now if you want to make this thicker in the back, and I don't know if I'm really doing a good job of explaining this, if you wanted to make this thicker in the back, thicker in the front, obviously what you would do is just shim this up off the table. And that would give you a transient line, a line that was thicker at one end, but it would be perfectly flat. It would be like a connected dot. And so just being able to do that has added even one more dimension. We know we can make these thicker and thinner. We know we can make them laminated. We know there's so many different ways these can be used. And just to have one more little bit of technology, it really, anytime you can get it, use it, share it, hey, take it to the bank and laugh every time one of your friends runs out and spends $18 for a nice soft block, carves it all up, and you have nothing left but a flimsy thing. They'd be glad that you can do molded shells. They are the way of the future. I spoke to Woody Midgley tonight. His ship is covered. His Brodak Cardinal is covered. I expect to get some photos soon. This is the ones we took for the little ad that's coming up in Stunt News. I just wanted to show these on the tape. I don't think these have been on already. And Woody, I think you're going to be the first one in the air because the weather here is terrible and we're busy doing this kitchen. No, I don't ever think I've been this itchy to get a plane in the air in my whole life. But this guy I'm really looking forward to. I know Rudy Rybeck's is almost done. I'm really looking to see how these guys are going to perform. Now I just wanted to thank Kent Ticer, who is in the middle of building up a Strega ring from ribs, and Phil Bailey, who gave me a call tonight too, to say that he's going to be doing up another Strega also. Glad to hear this stuff is so well received. And don't be surprised if someday there even is a Brodak Strega kit. Oh man, would that be a nice kit to have. An interesting picture from a ship that Roger Barrett had. And what Roger Barrett wanted to do is run an old VMAX motor, which was one of the original old tune pipe motors, with a muffler, and he had this custom-made muffler worked out. Kind of a neat thing. And there's the classic Cardinal. Believe it or not, Midgley still has this plane. These things last a long time, even in captivity, even when you give them to Midgley. Murderer's Row. See you tomorrow. This has been a long shop day and a long mail day. And if all this wasn't enough, you go to bed, you turn on ESPN, and they're repeating the old Spitfire show. Oh man, it just never ends. Never ends, ESPN. See you in the morning. I can't take this anymore.
To fit that fucking molding.
Hey, don't curse on Mike, I'm videotaping here.
Oh.
I want Karen to see her kitchen, what delicate care we're using modifying our kitchen. And this is this is Mike Kajeski, professional construction worker, formerly of the, look at this, holy mackerel, what a job! Oh my God, she's gonna die. This was my kitchen in here, and this was my, holy mackerel, looking good. Karen will be so happy. Oh, you got the heating vents in, oh my God. She'll be so happy when she comes home. Unbelievable. This is some job.
Okay. Where's that casing went?
Yeah, you think you're enjoying construction work until you see what a mess it makes out of your house. Yeah, even the dolls don't. Hey, stop getting me dirty. And believe me, next week John Brodak's going to be here to visit us. Oh my God. John, we have to clean up the house for you. Mike's working day and night on this so we can have a nice house. The only reason I mention this work, I'm down here, and as Mike is hammering away and jackhammering and everything, things are falling out of the ceiling. I had to cover all the planes up. I guess we're just going to bail out here for a couple days while he does his heavy work. Just want to give you an idea of what came out of this kitchen. Oh, Jesus. This was my kitchen, my heating vents. That was the studding. And you know, like what always happens in construction work, when you try to get a couple days where it doesn't rain, it's pouring rain. Oh, and we're trying to get this done so John Brodak doesn't have to sleep on a pincushion out in the rain here. Oh my God. And this is the killer too, these little nails. For about 6 months after you do any construction work, you find these everywhere. Oh, what an adventure. But anyway, we love our old house. And no matter how bad it looks, a month from now it'll be brand new. And if you've been one of the people that's been following the videos for years now, we've been doing this 11 years, you know, when we bought this house, this was nothing but a tar pit, and it's taken us just under 5 years to get it to this place. We can't wait to get the pond opened up come springtime, get our lawn furniture out, get our arbor going, some grapes growing back there. And I like to just look back and remember this on a nice cold winter night. Look at the old video of digging out here, George hammering the bricks in. It's the story of your life. It's the story of us all. Karen, you definitely need a pair of these stilts to make you a little bit taller.
Thank you, I appreciate it.
Debbie Burley wants to know, when you do your housework, is it normally Friday night or what?
Thursday, just the...
Oh, man. The mic is
And I'm here to help Karen.
Oh, man. Look at
I'm
this.
here with the vacuum, the shop vac.
We have a door. Now I can just see Oscar Van saying, Catherine, would you like to do it like that?
You already did her.
Don't you wish you could make fillets like this?
You got that? After that.
These guys that build toy airplanes, if they could do this, what you're doing to make the thing all nice and smooth? Mamma mia. Fantastic. This is great. I love the stilts. Maybe I could get John Bodak to make me some stilts so I could fly.
He's an electrician, just
Could be 9 feet high. Your bottoms could be 9 feet high.
knows everything. He said,
Yeah, that looks good.
For electrical work, the ceiling is down, the walls are down.
No, it isn't, Oscar. She's lying. I want to go build my plane. Oscar, don't believe a word this woman said. Look at what a sloppy house she keeps. Look, this is our kitchen table. The dust machines are going. Oh, man, when you do construction, what a mess. Oh, we got the Jolly Green Giant wandering around there. Mike, you got to fly with those things on. That would be cool. You pull a 6-foot bottom and you'd be right at eye level. It'd be great. I'm impressed. Get them for Sabatino, too. He could use a little height on his bottoms. Fantastic. How's that pie today, Mike?
Excellent.
The other day we had pie, the guy didn't cut it. We had to tear it apart and cut it with a sheetrock knife.
It's a little tacky today.
Oh, man.
Perfect. Look,
I'm telling you, look how he cut that vent in. Oscar, don't listen to Karen. She wants a whole house rewired for free. She's just looking for a free job.
well, free, I'll feed him for a week.
You'll feed him. What a sport, boy.
Gourmet food.
I'll bet Steve DeJulia and Oscar are going to fight to see who can get to rewire Wendy's house for free. Sure, they're going to fight it out. Yeah, this is what you get paid around here, too. You get Pepsi and pizza. Now, in today's mail, we got these I wanted to show these from Bob Martens. Get rid of all the little stuff now. Anybody that knows how we're working on this project for John Bodak, and these are the original templates. These are the original everythings, in fact. And what Bob did is he worked off of these. In fact, we'll separate these out to give you an idea of what nice work, quality work, Bob has done. But the fact is, everything Bob does is absolutely top drawer. None of this is compromised in any way, like just to get zipping along. Oh, these are beautiful. He even made me a couple of copies here for my own reference. Again, he puts a lot of time, there's a lot of time and effort into these drawings. Now we're going to be passing these on to John Bodak when he's going to be here next week. In fact, he's going to be here in a couple of days. And I hope he can, from these, he can do the lettering, whatever he feels is appropriate for his kit, since this really is his kit. But these are accurate drawings. These are really nice. And this is the kind of quality Bob always does for us. Now, Bob also sent in this rough sketch, which I think is a significant thing, and we definitely will be trying it. Remember how we made the hinge slider with the parting wheel and attached it to the side of the table and use it as a router and then just slide the block? Well, he's going to write this up and do, I'm sure, some kind of more Bob Martens-like sketch here for stunt moves. But in the meantime, share it with anybody and I know several people have been using the shells, so somebody's going to benefit from this. Let's hope it's you, and we will then be able to replace that wire or eliminate it altogether. And he went on in the letter to say that this is how they do it in the aircraft. Of course, he's an aircraft engineer for Boeing, just like Joe Adamusko works for Boeing. So, Bob, we really appreciate the drawings. We really appreciate them. They are definitely going to be an integral part of John Brodak making that kit accurately. Thanks a whole lot. Now, Larry Ladd of Kansas City is joining us, and I hope he's enjoying the tapes that he's been viewing. He sent me some pictures of his project that he's working on with his grandson, and I want to run these through. And I encourage him to get a couple of shots. I'm going to return these to Larry, but give me a couple of shots we can use in stunt news. Now, the only question I have to tell you, Larry, you got to do this, is get the monocoat iron and take these letters off and put New Jersey. Obviously, that's his grandson working on. Boy, tell you, if this doesn't bring back memories of when you were a kid and gluing things and cutting yourself with X-Acto knives, oh, man. And obviously, Larry's grandson has a nice workshop, or else he's using his workshop. Definitely a nice shop. Now, this is interesting. The caption for this picture is that this is a noblerized SIG twister under construction with my grandson. Hey, I have a great idea. Next time your grandson is ready for a nice project, get a Brodak Nobler kit, a fiberglass cowl, and maybe Wendy will even donate a free, remember that word free, fiberglass cowl if it's for your grandson, Larry. If it's for you, it's double the price. Nathan, look at this. He's got checkerboards. Oh, this guy really went at it with the kit. This is Larry's caption. This is the old Midwest kit, 1976. Has more flight time by club members than myself. In fact, Jim Lee flew it only 3 or 4 months ago. Keeping with the Warbird theme, the John Brodak, I guess, Warbird theme of, I think this is a great idea. In fact, there's others. Here's the caption on this photo. Carrier plane from Leroy Cordes Plans was built by me in the mid-70s. Nice idea, by the way. And again, more in keeping with the John Brodak Warbird theme for profiles. Hope we're going to be seeing a lot of this in the future, since a lot of people really like semi-scale, but they don't have the time to do an intricate Billy Woolridge type P-47 or a Paul Walker B-17 or whatever, or an Adamusko Spitfire. Pretty much anybody can crank one of these profile guys out. I think Larry's rubbing it in when he says February in Topeka, Kansas. Larry, we don't fly in February in Jersey. That field is underwater. Looks like they have a nice place to fly here. Now believe me when I tell you, I can relate to this. Home from the Topeka field, just a little tired. I have to tell you, there was many times when Harold Price used to take Carl Wahlberg and I flying, and we couldn't even stay awake on the ride home because he had us launching planes and wiping planes off and sweeping the flying area and every other thing, wiping his plane off with pledge for him. Hey, it's a good tired. Now Larry passed on a little tip. He said his grandson likes these cartoon kind of pilots. Well, several guys, including Doug Benedetti, who love these things. That's a good idea if you want to keep it light and whimsical. And the final picture, the caption is, "My 25-year-old ringmaster." Larry, I hope you and your grandson are having a great time. I really appreciate that you've shared the pictures with us. In fact, I'm such a cool guy, I'm going to send you a copy of this tape for your grandson. And if you get that grandson, now look, this is a promise. You got this on video. See, if you let this guy build a Brodak Nobler, we'll send you the cowl for free. No charge. Anybody under, how old is your grandson? It doesn't say. Well, anybody under that age gets the cowl for free. Anybody over 50, they have to pay double the price. Anyway, Larry, thanks a whole lot. Say hello to Jim and Lila Lee while you're at that field flying, while we're over here trying to keep our field from floating away. Could have made the Titanic movie on our field. I got a couple other photos in today's mail if I get them all on at once. This is from Jack Young. He's from Whittier, California, and he's been building a Kestrel, and you can see by looking at this that he's really got the thing pretty well under control. Boy, that's a lot of ribs and wing. I never realized how many ribs were in that wing. It's almost like an I-beamer. Well, there's a nice picture checking that the two flaps are in alignment. Now, it looks like from this picture he's using a molded top block. He's got a foam molder, which definitely is another alternative good way to do it. And even using that method, you could use Bob Martens's way of trimming it off. Just a lot of good one kind of technology working with another. It's another construction photo. Looks like he's putting the horn in, joining the stab halves. It was a really nice letter that Jack sent. I'm really moved by it. A nice complimentary letter. He said how much information he got off the videos. And I hope one of the things that he's having a problem with, I hope he can resolve it, is he's running 7 ounces of fuel. Well, there's a lot of things you can do, and you can pick most of them up off the engine tuning videos, but basically if you're running too much fuel, I'd say more than 6 ounces of fuel in a 60, you should be thinking about a Hemi head if you don't have one already. Some more head shims, a little less compression, a little bit smaller venturi, and 5% nitro. Just some of the alternative things to get better mileage if you need to. Or you just buy a bigger tank, have Doug Taffender make you up a custom tank. Anyway, Jack, appreciate it a whole lot. We're going to get back to the shop. It's time to get back to what we do best. Avoid work. Tom Dixon passed on some nice information here for anybody that's interested. He's making kits of both of these planes. Now, I'm not familiar with this design, the NAKKE. I can't read because it says it's classic legal. Anyway, kind of a Skylark looking plane. And anybody that's interested in either the plans or the kits should contact Tom direct. He also is making a plane that's called a Time Machine. I believe this is a variation of Big Jim's Pattern Master. It has the look of Mike Rogers' old Pattern Master, or really even a Stiletto, whatever. And of course the top is made with, I don't know if anybody's familiar with the way a real PM is made, not one of the variations, with like a Stiletto is with pieces and corners. They're both foam wings. This is Tom's unique foam wing. I don't know what he calls it, the kept foam method. But anyway, he also sent in some good information that he's going to be very soon be making available zinc sterate. Now, Randy Smith has been selling that as filler to replace talc. We don't have any, but Tom is going to send me a sample, and I'd be interested in trying it. Of course, we're always looking for any new stuff. Zinc sterate, S-T-E-A-R-A-T-E. Now, there's several different things, just to mention, several different things that from Q-cells to Cabicil that you can put in paint as a thickening agent to make filler. You can put any number of things, but zinc sterate, it seems like a lot of people have been happy with it, so we'll be looking forward to getting a sample of that. Anybody's interested in these, and I believe they're even going to, they're kits. should just contact Tom direct, and I'm sure he'll send this out to you, the same thing, or even the full-size plan. And we've finally gotten, I guess we're down to about 200 of these we've made. God, we've used almost a gallon of material, and an ounce makes 2 pieces. But you can see what's happening now as time goes by, and because this was really not the correct rubber to use at the time, this was the only stuff we knew about, but little pock marks develop as time goes. Obviously, the average person doesn't need to make 200 of these, but as it deteriorates, then you have to clean each part with either your fingernail or sandpaper. So what we're going to decide to do when we do get to the point of making these exhaust manifolds, for the new ship, we're going to make the Siamese ones, where 2 go into 1, and this is the plan right now, and I'll be detailing that out. And we're going to be using a little bit better quality rubber, so if the time ever comes, a lot of people have bought these and put them on Mustangs, Mosquitoes. There's even some on Hawker Hurricanes. Some of the scale people even use them. But the mold does not have an infinite life. In fact, this, I was disappointed by. This is that art store rubber that really isn't the correct stuff. The new stuff that we're doing a nobler cows with is much better. But we accomplished what we wanted to, and the cost of this was very low. I'm only putting this on here for reference so that people understand, at least the lessons that I've learned. Is one of the valuable lessons that you can learn is you can't spend, you can't buy, or try to save money on the original molding rubber. You really have to buy industrial quality stuff if you want to get 100 or 200 parts out of it. These parts, the original parts, the first maybe 70 or 100 came out really nice, and then little by little this mold has basically deteriorated to where we can hardly use it anymore. It really, in terms of modeling it, isn't a big deal, because you would sand these down anyway and fill in any little bins with the putty. But what it does, it makes the production of them a little bit more labor intensive than we'd like it to be. And since we're selling these basically for $2.50 each, and the resin costs $1, there's really not a lot of profit left when you count the cost of the molding rubber, other than the fact that you have a nice unique scale part. So that's one of our projects we will be slating, is for some new molds for these little exhaust guys, and especially for this new, the early mark will have the Siamese exhaust. Now this was, and again, these are the little things that make the world of modeling to me very interesting. When we started this, we really didn't have any clue, any idea really how long the mold was going to last, how effective it was going to be, what material we were going to use. But you can tell, and I guess that's part of the adventure of any modeling thing, is when you have the materials right, that's a big part of it. Or if you have somebody you can call. Now in our case, we really didn't have anybody we could just call up and get the latest information. But we certainly had a lot of people that, now see, all this guy needs is to be trimmed. And that's how nice they come out of the mold now. And that to me is, that's a pretty sophisticated part for somebody that's not a professional mold maker to do a layup on. Just to give you an idea of how many of these we've made so far. And we have, that goes in all the latest ones, a list of directions on painting. We seal each one up in a plastic bag so it doesn't get damaged, but see, this is the learning curve anybody has to go through. I think we got about 10 left here. We've sent a lot of these out. I've gotten feedback from a lot of people that have had really good, most people have had excellent luck with it, so I count that as a nice, in fact, we got anybody that doesn't have one of these, the sheets that we use, it has all the little tips and tricks that we've come across well, basically that Ken has come across also in doing his model. And this is one of the things that I just feel like, well, we can contribute this. Yeah, it's just a little tip sheet. The next thing I want to do is I want to make up a 21-inch arrow shaft. That's the tail moment arm, and that's longer because we've changed the hinge line, in effect, and we're shortening the span of the stab. At the same time, it's going to result in an inch longer tail moment arm, which I think is going to be more scale, and we're still in the parameters of doability. Both of these planes came out relatively nose heavy, so this would be one of the, assuming we're going to wind up with a tail that weighs roughly the same amount when we're done. But anyway, these are the minor adjustments that we're making as we're going along. The next step here is I have these already drilled out, similar to doing the other part of the push rod, and I want to assemble one end. I want to get one end on here, then from the first end, I'll reference back, and I want to leave myself about an inch of adjustment so that I can fine-tune the push rod length with the joint like I've done on both of the other models, and that's worked out to be an excellent system, totally bulletproof. And actually, the truth is, on both models, we have made adjustments that have increased performance. So if we didn't have that hatch, and we didn't have these little gizmos, we'd never really be able to fine-tune that final feel, that final little bit of the turn. I think Paul Walker called it the turn quality, and that's really an apropos term. And one of the things to remember when you're making a push rod is you want this to be a tight fit. You don't want this to be a sloppy fit no matter what. And getting that precision drill is a big part of getting this right. Now you also want to go up here and just eyeball up and take just enough of that bend off so you get that nice hook and just a couple of thousandths stick up above the arrow shaft end. So many people, and it's hard to understand that, well, when somebody's new to this, that they might not have figured this out, and the directions that come with the arrow shaft kits, they're not really as complete as they should be because they're made for RC planes where they're not using this kind, exactly this kind of, there's not this kind of strength required in the parts. Now, a good way to trim this, and I don't think I put this on the video so far, but a good way to get this trimmed on the first shot, or maybe the second shot even, is to kind of lay out how much you want to put on here, how much you want that to stick out, and hold it with pliers. What happens, in this case it's vice grips, what happens normally is you either cut this too small and then nothing sticks up, or if you cut too much you can't get it down into the arrow shaft. Now, better to cut it a little long to start with. And you want to hold it this way because otherwise that wheel catches and it just jumps out of your hand, breaks the wheel, and you can get hurt that way. And always wear some eye protection when you do this. I want to lay out some on one end. Again, a precision 093 hole just a little bit further back than the end of this. Now you always want to do a little test for here, make sure the wire is sticking up enough when it's in the center. If you have it that it's just sticking up just a little bit, there's a chance it'll drop down and then you won't maintain integrity. And what happened, and we know this is embarrassing, but it's true, we have seen several people that have just shoved the wire in and not put this piece up and glued it. And yeah, it'll last a week or so, or a couple of flights anyway. But anyway, you want to have that piece up there. Now another thing, you can dress this end off, the plastic end, because what happens in here again is a flashing on it. It makes assembling this relatively difficult. And you want to have a nice tight press fit. When you press that in, you want to have enough sticking up out of there, and of course I'm going to wrap this with carbon fiber again, and then bend my end. Now I've seen several people do this. They make an arrow shaft and leave a 7-inch piece on one end. Well, this is what happens. See the difference between the arrow shaft and that? You can't do that to an arrow shaft. This is rubber controls, this is bulletproof controls. So obviously on the end it's not going to have an adjustment. We want to make this as short as possible. I personally like to have this piece either one of two things, either facing in at me, even though this is unnecessarily redundant, or facing straight up. And the reason for that is if I need to ever make a fine adjustment, I can cut in through the plane, elongate this hole, heat this with the tip of a soldering iron and make a fine adjustment here. But I'm not really going to have to do that on this part because I'm going to make an adjustment down at the other end where I can make a fine-tuning adjustment for the elevated to flap ratio. Again, you're trying to bend the wire. Vice grip pliers are good, but if anything, bend it just a little bit, not enough, and then bend it little by little back to 90. Don't bend it past 90 and bend it back. Always try to put, again, remember what the rule is. Don't kink and fracture the wire. The radius here should be a nice smooth radius. Don't try to pinch it and never bend it back. And these little tiny grooves, once we get an eyelet on there reversed, and what we'll do is these are the safety wire redundancies that we're going to have. And always, these are the things that make, I guess, common sense. They're free, they're common sense. You always want to have the push rod in the system so that centrifugal force is pushing it out. So if this, in the middle of a flight, this washer 10 years from now falls off, centrifugal force would hold that in place until, hopefully, till you land, and then it would fall off. It's a free redundancy. You always want to use all the free redundancies to your favor. Next thing will be a repeat of what we did with the carbon fiber toe. Seal this with thin CA. Wrap it a few times around this area here. Fill it inside with thin CA so that this all gets nice and solid. And a few wraps here. The reason being, in a carbon fiber arrow shaft, all this material is unidirectional. It has no strength, I shouldn't say no strength, relatively little strength in this dimension of splitting it apart. All the strength is in the push-pull dimension where we want it. And even if you didn't have any carbon fiber toe, wrapping this with some string would even be okay. Anything just to strengthen this last little bit. Now, I used to have a real neat system. I had some arrow shafts that slipped over the outside of this, and I would just put a little donut of that arrow shaft on there. I don't have any more of them, and I'm not going to spend $10 for an arrow shaft. These oversized arrow shafts are about $10 a piece just to do it. The carbon fiber toe works just as well. Now it's easy. It's just to tack glue one end of this, and then you can kind of wrap. Makes it a little bit easier to wrap it anyway. And I've said before, anybody that needs some carbon fiber toe, be glad to send them enough to do a couple sets of arrow shafts for no money at all. Because this is one of the safety things you sure don't want to risk a whole winter working on a plane and have an arrow shaft split, and they do split under heavy-duty use. Good old bug mechanic sanding sticks in action. And you give this a couple of coats of thin CA, it blends in really nice. Now the other end is going to be quite similar to this, except I won't have this bend here, so there's no point in putting the whole thing on again. It's the same thing, but I'm going to leave a little stub sticking out here with an extra inch, and I'll put that adjustment on that end. I want the final length to be 21. I want to have my little adjustment, so what I want to do is probably leave about 3/8 of an inch, and then I'll bend up my other little piece of wire. Total length of this push rod is going to be 21 inches. Let's see just how much I want to obviously leave myself a little room for adjustment. Now I just need two little soft copper wire wraps here. I'm going to silver solder this with Stay Bright, deflux it with baking soda and water. Make sure that the two push rod ends when you sight down are nice and level. I put the notch in there, and then I want to make sure my overall length is exactly 21. What you want to do before you actually do the soldering thing is you want to tweak this. You want to make sure these two ends line up. You can see that they're both in alignment. And obviously you want to do this before you solder it. Now it's always tempting to want to put one little piece of copper tubing or one of those little couplers on here. And if you do that, and I've seen many planes just go in and have a push rod failure, because what happens, you trap a little bit of the sulfuric acid inside that tube, and it corrodes the tube away, and in a matter of X amount of flights, you wind up crashing. So this is the kind of joint, and I want to have a good, nice, solid, clean joint on here when I'm done. Nice, shiny joint. Now I like to go back over the joint once I know it's set. Make sure the whole joint, when you pull the soldering iron away, it's nice and shiny and smooth. That's usually an indicator you have a good solid joint. That completes our magic push rod. And that'll give us that little fine tuning that we need. Hopefully we'll have it if we need it. If we don't need it, even better. Well, we're almost at the end of this tape. I want to thank everybody for joining us. Please pass the tapes along. Pass them around. Get that information out there, and let's get a lot more people flying stunt. And the ones that are flying stunt, let's get them to have more fun than ever. And our kit is really coming along. We're going to set up the wing next time we get a chance to work on this. Get the table level. Get this all framed up. Can't wait to see this in one piece. It's coming. And this is the whole idea behind building a kit like this, is at some point in time, you hope it'll just go together. And what we really look forward to is seeing this guy take shape and become a Spitfire. And a special thanks to Bob Martens for doing a slam dunk job on those profile cardinal plans. Let's hope the day's coming when there'll be many, many of them flying. Oh, I love that 5-bladed prop. Giorgino's working on a pilot. It's a real team effort building one of these. Special thanks to Joe Adamusco for laying out